And so hello, welcome. So before continue, just start by saying, okay, we left off over here. I'm not sure if there are careless mistakes, so we'll just take it as it comes. To sort this thing out, we'll try and simplify all of this eta over y's and everything first. So let's substitute again eta over y here. Okay, so let's substitute eta over y. Okay, eta over y, what is eta over y? Okay, eta over y is this. Okay, again we'll use the same substitution. Where is it? Yeah. So it's half square root of whatever that thing is. Okay, half. Okay, square 1 over x. 1 over x, because it's yeah, I'm going to do this in terms of the Reynolds number. So it's actually 1 over x square root of the Reynolds number of x. Okay, 1 over 2. Alright, perfect. And again we're going to see some nice cancellations. Okay, so let's cancel things out. The rex and rex will cancel out. Okay, and you see this L and X, we will combine into X star. So I'll take the L out, and the 2 halves will become 1/4. So 2 halves will become 1/4. Okay, so we'll just have this form of the equation. Okay, we have this form of the equation over here. On the right hand side, I guess we can just change it up a bit. Right hand side, we have alpha and everything here. So we'll just do the eta square over y square. We'll take that out. So I'll put a fraction 1 over 4, and you have fraction rex over x square. So I kind of do the very quick run through of that. So half times half is 1/4. X 1 over x times 1 over x is x squared. Re to the half is just re. Okay. Alright. That's one. So I can actually start cancelling out some things. So I have x into x star because I'm going to combine with this L over here. Okay, I'm going to combine with the L. Then I'm going to multiply throughout by x star. Okay, multiply throughout by x star. Multiply throughout by x star. And okay. Of course, you could also multiply throughout by 2, and that'll be good as well. Or you can multiply throughout by 2 or 4. So let's multiply throughout by 4, so you get rid of all the fractions. So this 1 over 4 disappears, and this becomes minus 2. Okay, so what remains here is to combine. Oh, there's still one more eta over here. Okay, I kind of forgot about that. Okay, let's see. There's a u and an x over here. So, and there's an eta over here. So let's do something about the eta. Okay, the eta, you'll substitute it out. Okay, we'll substitute out the eta. I don't know why I'm giving 2 spaces for that. Let's substitute out the eta. And I'll have fraction 1 over 2 fraction y over x, and then you'll have rex. That's eta. Oh yeah, square root rex. Alright, so 2 and 2 will cancel. So it's mostly done. So the 2 and 2 will cancel. I'll just have minus half over here. Or this whole thing will just be a minus half, minus 1 over 2 theta prime f prime, all of that. Okay, now, so we have things in powers of the Reynolds number. Okay, wow. Okay, this doesn't seem to be working out. Okay, let's see. Where's the... I think there's a careless mistake. Oh man. Okay, so here's the thing. I think I started out with a wrong assumption that the V had a minus sign in front. There's not supposed to be a minus sign. I think that's where I got the careless mistake. And I'll probably have to change the fluid mechanics as well, because that's where I copied it from. So that's the thing. That's what happens when like I don't derive it from scratch. I think I copied it wrongly. So take note. Yeah, the V is not supposed to have a minus sign in front. No wonder. Could not work out the thing. Yeah, it's not supposed to have a minus sign in front. So we'll have to start copying. Start from there. Okay. Let's see whether we can fast forward this bit. I'm going to go back to where we started. Okay, we can start by making substitutions. Oh, we start by making, okay, that's where it is. That's where the U is, and then we'll need to change the V. V characteristic is the same, and I'll erase the minus signs from here. Okay, let's fast forward. Okay, so where else does a minus sign? Well, the minus sign disappear here and here. Okay, so the fraction of half in front will have no minus sign, and go all the way down to replacing the leftmost term, saying that half will have to disappear. The minus signs will have to disappear. Okay, 2. Okay, fast forward. Okay, so now what I did is to disappear all these minus signs out. I will need to go to the bottom where I say substituting back in. I will get rid of these minus signs as well, so I'll fast forward that part as well. Okay, so now these 2 minus signs will disappear as well. I will need to change them to a plus sign. It's 1 and 2. Oopsie. Okay. Alright, so now I actually so-called multiplied the minus sign in. So this front should be a plus, this should be a minus. So let's go to the half eta y part. Plus half minus half. Plus half minus half. So this will be a plus in front, and the other term will be a minus. Okay, now that this seems to make more sense. A lot more sense, in fact. Okay, So let's keep going. Of course, we find out that this is a plus, this is a minus. I'm going to change all these signs throughout, and you'll notice this term will actually disappear. Okay, so simplifying plus minus. Okay, I'm going to fast forward this bit as well. Okay, so now the important thing is you notice this term actually disappears altogether. Okay, minus 1 over 4x star plus 1 over 4x star. So the leftmost term disappears, which is good news for us. Now everything is simplified all the more. Okay. So this is still the half and half thing, and I'll just get rid of this part, and all the steps kind of remain the same. I'm just getting rid of the leftmost term. So I'll fast forward this part as well. Okay, and one more thing, all the f prime theta terms, these terms will all have a minus sign in front. Okay, all of these will have a minus sign in front. So let's do that as well. Okay, so now this looks way better than what it was previously. So other than that, all of these should remain the same. We'll still have a Reynolds number thingy here, based on x, Reynolds number x. The x star of course disappears, so we'll just have rex over x, and I think these two other things are pretty redundant, so I guess I can just use them as a way to let's see, yeah, as a way to how do you say, yeah, as a way to yeah, put in more terms as part of working. Okay, so what's rex? Okay, let's just expand it out. Okay, it's actually ux over nu, and that u is actually u infinity. All right. Okay, so plenty of things disappear. Okay, plenty of things disappear, and we'll notice that we are going to be left with just u infinity and x, u infinity of x cancel. Yay. Okay. So let's cancel those, and we will just get alpha over nu, and that is great because that actually is our inverse of Prandtl number. Okay, alpha over nu, and I think we are pretty much done. Okay, we are pretty much done with our so-called derivation. Yay. So let's just call this the Prandtl number, 1 over Prandtl number. Yeah. 1 over the Prandtl number. And we'll just condense this equation together in the following form: theta double prime plus Prandtl f theta prime equals to 0. Now we have a similarity solution, at least the ODE, and this ODE is pretty easy to solve because it's actually linear and homogeneous. You can just separate variables and your job will be done. Haha. Yeah. So in other textbooks you may notice that there's a factor of half in front. It is different, I guess, because of the way you define eta. Okay, I define eta with a half in front because this is the way Blasius did it, so I just copy and paste. But the way other people define eta, for example, in a later time, eta, they take out the factor of half out, which is totally fine as well. It's kind of immaterial, just that it will result in different looking ODEs, and of course the slightly different results. But the end of the thing is that, yeah, everything at the end should be the same. Okay, everything at the end of the day, everything should be the same. So yeah, let's see. Okay, we're 15 minutes in. Okay, so I'll stop the video now. Next video we'll try to talk more about boundary conditions and solving this. Okay, we don't have to use a numerical method to solve this. If we already have values of f, we can just use those. We can plug in those values there, no problem. Can plug in those values of f, and what else? Yeah, plug in those values of f, and you just we perform integration. It's that simple. All right. So long, guys. I'll see you again.